In this video, I'll discuss structured exception handling in C#. And basically an exception is anything that happens in your application that you don't want to happen or you didn't expect to happen. And computers are not like humans. They can't adapt to problems as easily as humans can. And so what happens when you don't handle an exception? Well, it's not a pretty sight. To illustrate this point, I've created a really small application, a console application that has one line of code in it. And it basically creates a file stream object, and in the constructor of the new file stream object, you're to pass in a file name that you want to open. In this case, I want to open, and there's other choices, save, or whatever the case might be. But here's the catch. I don't have that file on my file system. It's not at c:/lvs.txt. So what will the application do? Let's go ahead and build the project. And I navigate to the project on my hard drive, go to the bin directory, debug subdirectory for that project, and I'll type in CS exception. And what happens is a screen comes up since we're in the debugger, and it just-in-time debugging screen. An exception, system IO file not found exception has occurred in your application, and it asks for which debugger do you want to use. Well, clearly we wouldn't want our users to see either this or any kind of debugger that pops up right when they're trying to use the application. So to avoid this, what we want to do is structure our code in such a way that we can handle exceptions. Notice that after I hit the No button, it gives a whole list of information about what the problem was exactly and some possible solutions. We'll talk about all this in a moment. So since we don't want our users to have to see those ugly error messages pop up whenever they're using our application, we need a way to handle the error and then deal with it appropriately. And that's what structured exception handling or structured error handling allows us to do. It's actually an organized approach to handling exceptions, and it promotes good coding practices. And we'll talk about some of the ways that it does that in just a moment. One of the ways it does that is that it allows you to check for the source of the problem, the actual problem, and deal with it appropriately. So based on the exception object that you get back, you will know exactly what the problem was. This is a lot different from perhaps what you did in VB6 and earlier and maybe other programming languages where there was a homegrown way of error handling. You may have go-to statements and labels and things of that nature. Structured error handling promotes one way to do it across all .NET languages for all .NET programmers. So this is something we really need to take advantage of as users of .NET. If you come from a Visual Basic background like I did, it might not be obvious at first some of the benefits of how .NET handles exceptions. But once you get the hang of it, you'll see that there are some huge benefits in the way that .NET handles exceptions. First of all, there's a concept of exception objects, and there are dozens, maybe even hundreds of different exception objects used within the .NET framework. And they can be very specific, like the one we saw with the file system error, where there wasn't a file found. So you have an actual object that gets instantiated and passed back to the calling application or method. And then there are some more general ones, like, for example, if an instance of an object is set to null and you were expecting there to be a real instance of that object. You might get something like the object reference not set or object reference null exception object passed back to your method or to your application. And so one of the neat things is that all of these exception objects are common across all .NET languages. So if you have different components, you can raise or throw an exception from one of your components into another component or into the calling application, and they know how to handle it. It's not something that's foreign or has to be custom coded for your company or for your particular applications, like maybe the way you did it back in VB6 and before that. And exception objects can be created and thrown across process and machine boundaries. There's really two concepts here. First of all, you can create an exception object and throw it yourself if you think that there's going to be a problem within your application. So maybe there's some things that are happening in your code and you detect that there's a problem, and you can create and throw your own exceptions and throw that to any calling object that that might be using your component or whatever the case is. And then also those objects can be used across other processes and across machine boundaries, because they're just like any other .NET object that can be passed around in that manner. They can also be passed through web services. They can be deserialized into XML and then reserialized back into an object. So there's a lot of flexibility there. Also, and this is the neatest part, you can check for specific exception objects and react differently for each one. So in structured exception handling, you might have 5 or 6 different exceptions that you can check for on a given statement or two within your code, because there might be different things that come up. Like in our case, there was a file not found, but what if the file was corrupt or there was a write protection on it? And we're going to see some examples of that in just a moment. Also, since you have this type of exception handling, I guess one of the results is that you don't need return codes. I remember back in the VB6 days, in classic VB, you might return true or false for a method if it worked or if it didn't work. Or you might return 1 if it was successful, or 2 if there was an error, or you might return the specific error number. I think that was pretty common across many of the applications that I've worked on. But when you're using structured exception handling, you don't need to do that. All you do is just raise the or throw the object back to the calling method or calling application, and then it should be able to handle any type of exception object that's passed back to it and react accordingly. The next point I kind of made a few moments ago. You can raise any exception that you want and throw it at any point in time. And then finally, you can also create your own custom exceptions. Now, this is an advanced concept, but it can be done. The danger here is that any applications that use your components have to have knowledge of this exception object that you create. And so there's some gotchas and things you got to watch out for whenever you're doing it. But we'll cover that in a future video. Now, we said that there were dozens, if not hundreds, of different exceptions in the .NET Framework class structure. However, all the exceptions derive from the exception class, the exception base class. And there's some common properties across all exceptions that you can be aware of and utilize whenever you write your applications. And they are, for example, the stack trace, which gives you all of the method calls that led up to that particular line of code that actually broke the application or was unexpected. And this allows you to get some context and understand better the exact spot where the exception happened within your code. Now, often you don't want to display this to the end user. By default, in ASP.NET applications, you're going to see that come up on that yellow default error screen unless you change the web.config to allow for that and show a custom error page. As we just saw a moment ago with the console application, it's going to display the stack trace method call chain, and you don't want your users to see that. But that's something that from a debugging perspective you can use and find out exactly where the problems are. There's the inner exception, which shows this has to do with whenever you have a chain of exception handling. For example, you might handle an exception that and it throws it back to a calling method that throws it to the calling method that throws it to the calling method. So you might have several different calls in the stack trace. And the inner exception will allow you to get to the original exception that occurred that set off this chain of exceptions that went up through the call hierarchy. The next is the actual message of the error, and finally the help link where you can find more help for that particular problem. Before we get into a source code example, there are 2 types of exceptions. First of all, there's the .NET runtime exceptions, things like execution engine exceptions, Stack Overflow, out of memory. These are the kinds of things that you can't handle and that you can't recover from. Then there are application exceptions. These are things like invalid cast exception, where you try to convert something into a type that it can't be converted into, or argument null exception, or argument out of range, or null reference. index out of range. There's literally dozens of these, and you have to handle these types of exceptions or else your application bombs, as we saw earlier. So without further ado, let's talk about how you do structured exception handling in C#. So what we have was that modest application from just a few moments ago, and we're going to modify it to actually wrap around it the try-catch statement, which is how you handle exceptions in .NET. So you have try, and the try says these are the lines of code that we want to attempt to perform. But if something goes bad, we want to catch any problems that might occur. And the catch statement is going to pass us back an exception object. Now, in this case, we're just going to catch all exceptions that happen and not make any distinction across any types of exceptions. So we might have, for example, the one that we saw, which was there was no file on the system. I think it was a file missing exception or something along those lines. It could be one of those. It could be a different type of problem. We don't know which one it is. We're just going to catch any problem that occurs here. And what we'll do is just write it out to the screen. Now the benefit here is that we're going to handle the exception instead of letting the compiler attempt to handle it for us and make a mess of things. So here we go. Let's go ahead and save this. Let's build our solution. And then let us try to run our application again. Now this time, notice that there's still a lot of text. We did not see that just-in-time debugger pop up, first of all, because we handled the exception. And then also I want you to notice that the only thing we really did here was that we added this, the error was, and then we let it print out just like we did with the rest of the error above, where we actually print out the entire text of the error. Now you might be saying to yourself, okay, so big deal, all you did was print out the error. Well, there's some other things that we can obviously do, and so let's get into a more advanced example. So here we are back in our source code, and what I want to do is just cut and paste some code that I created. And here we're going to add another catch statement. This catch is a specific type of exception called the file not found exception, okay? And what we'll do instead of just writing out the entire error message is something a little more friendly. Oops, wrong file. So let's go ahead and save that, build the solution, and then let's run it again. And notice this time that we have, whoops, wrong file. So the most important concept here is that we added a second catch statement so that we could get more specific with the types of errors that we're trying to locate before we use the all-encompassing catch exception E within our application. Now let's expand this section, the catch exception E, to show you another feature of the exception object, and that is some of the properties that we can use. So to do this, I'm just going to comment out this line and paste in some lines of code that I've already created. And here we're going to catch the inner exception and print that to screen, the help link, the stack trace, and the message to exercise some of these properties that we talked about earlier in the slides. And then also what we're going to do is comment out this line and produce a different type of error. Now in my folder where the project resides, LVS projects CS exception, LVS TXT, we're going to try to create a new file by that name and see if we can accomplish that. Now there should be an exception thrown as a result of this, like the file already exists. You can't just create a new one that's called the same thing. But I'm not going to catch that specific exception just yet. I'll show you that in just a moment. Instead, what we're going to try and do is trigger this second exception and then have it print out all the specific properties of this exception object. So I'm going to go ahead and save this, go ahead and build, And then we're going to bring up our command window, and we're going to hit F3. And let's take a look at some of these things now. So the first one was the inner exception. Here, let me do this again. There we go. The inner exception was, and there was no inner exception because we really didn't have a call chain, so it wasn't pertinent to this particular error. Also, there's no help link apparently associated with this exception, so that's blank. You're going to have that sometimes. Then you get the entire stack trace, and this is very similar to what we saw whenever we didn't handle the exception, or whenever we just by default printed out the exception. So by default, stack trace seems to be the default exception property. And then finally, we have the message was the file already exists. So in order to handle this more specifically than just allowing our default error handler to capture it, we'll go ahead and stick in this other line of code, catch IO exception, and that will say this file already exists, and we'll just do this really briefly because this isn't the point that I want to get to. This is on our way to another point. Hit F3, run it again, that file already exists. Great. So we know we have the correct exception now. What we want to do is show how you can wrap exceptions or exception handling in exception handling. And let's do that by going try, and then we'll go down here and notice how it moves everything over to the right a little bit, and here we'll put another catch. And I'll just paste some code in here. That console.write, the exception that was thrown was whatever the exception that was not handled. So what we're going to do in this particular one, just to play devil's advocate here, is that we're going to capture the exception and then throw it to simulate throwing it to the calling method or the calling application by wrapping the try in a try. So what we'll do is we'll find the error. This will be the problem. We'll write out an error message, and then we're going to take that exception and throw it back up to the level above it, which in this case is another try statement, but it could have been a calling method or an object that called this particular method if this were more of an OO type application, I guess is what I'm trying to say. So we're going to throw a new instance of the IO exception object, and we're going to pass in that file already exists on the hard drive into the constructor. And if we did this correctly, what should show up is console.write, the exception that was thrown was, and then it'll give us that message that we passed into the constructor. So let's go ahead and save this and build it. And then let's see what happens when we run it this time. Let's clear everything out and then go CS exception. All right, notice what happened here. You have the original error occurred and it wrote out that line to the console window. And then we threw the exception and caught it at a level higher than that. In this case, it was in the same method, but it could have been in a different method completely. And we handled it there again. And we handled it by saying the exception that was thrown was, and then that string that we passed in. So the important concept there is that you can handle the exception and then create a new instance of that exception, or create a new instance of a different exception and pass that back up through the chain of calls, or the chain of try catches in this case, in order for other methods to be able to handle it as well, to determine what it needs to do now that there's no file that exists. It needs to modify how the rest of the application is going to behave. It was expecting to perhaps, I don't know, open up the file and read it and print it all to the screen. But now that it can't do that, it's not going to call that other method to print out to the screen because it returned this IO exception object from this method. I don't know. You come up with a scenario on your own, but the beauty of this is that you can create your own exceptions and throw them up and let the calling application handle that. I'm going to do one last thing here. Okay, the last thing that I want to do is show you how to use the finally statement. And I'm going to paste it here after our string of catches, catch, catch, catch. Right after the last catch, I'm going to insert a finally statement. Finally, console.write, that's all, folks. Now, what a finally statement does is it cleans up any messes that you may have made. It will, for example, if you have a connection to a database, you need to close that connection and set that reference equal to null. And you can do that in the finally. It will happen no matter what, no matter if our try statements completed successfully, no matter if any of our catch statements fired off, the finally statement will occur before we pass or throw any other exceptions up the call chain. So in this example, we would expect this line of code to execute. We expect this line of code to execute as well, but it won't happen before this because this line of code is throwing the exception to the outside try. This line of code has to execute before we relinquish control to the outside try-catch structure that we have here. So what will happen is, if we did this correctly, we'll see the line, the file already exists, then we'll see the line, that's all, folks, and then we'll see this final line. The exception that was thrown was, and then the actual message that we threw into the constructor. So let's go ahead and save this and build the solution. And then let us type in CS exception and run it, and sure enough, we have our, the file already exists. Great. That's all, folks. That's in our finally statement that runs no matter what. And then we have the exception that was thrown was statement. So in closing, I wanted to give you some practical tips, just two. First of all, don't overuse the try-catch blocks. They are definitely slower than just trying to run the code by itself, especially in looping scenarios where the effect of the performance hit is compounded. Instead, what you should try to do is check for the most common problems. So if you have an object that you're going to reference, is the object null? Check that first, and then if it is null, handle that. Are all the parameters populated? Check those first before you actually call that method. And so there's a lot of things you can do in kind of in a preventative mode to make sure that you don't need to use try-catch blocks all the time. The other thing that you can do is order your catch statements from the most specific exception to the least specific. You'll notice in our application we used the catch exception E at the very end of all the catch statements that were listed, and that's what you want to do. And there might be several layers of specificity, I guess you'd say, from exception to exception, and so you want to use the most specific ones first, the most general last.